In this video, we're going to cover what the term mole means, and see how we can use this formula to convert between moles, mass, and relative formula mass. Now, the term mole is a bit weird, but really it's just a unit we use to measure the amount of chemical that we have. So just like we measure distance in meters and time in seconds, we can measure how much substance we have in moles. And 1 mole of any substance is just the amount of that substance that contains 6.02 times 10 to the 23 particles, with particles referring to atoms, molecules, ions, or even electrons, depending on which substance you're talking about. So if we had a little pile of carbon, and we were told that it contained exactly 1 mole of carbon, then there must be 6.02 times 10 to the 23 atoms of carbon in that pile. We call this number Avogadro's constant. And the reason it's this specific number is that the mass of that many particles of any substance will be exactly the same number as that substance's relative atomic or formula mass in grams. So our little pile of 1 mole of carbon would weigh exactly 12 grams, because carbon's relative atomic mass is 12. Meanwhile, 1 mole of oxygen, which has the relative formula mass of 16 times 2, so 32, would weigh 32 grams. Or 1 mole of CO2, with a relative formula mass of 12 plus 16 plus 16, and so 44, would weigh 44 grams. But in all these cases, there would be 6.02 times 10 to the 23 atoms or molecules. Because of this rule, we can create a formula which tells us that the number of moles in a sample is equal to the mass of that element or compound divided by its MR. So if we want to know how many moles there were in 42.5 grams of ammonia, we would do 42.5, which is the mass, divided by 14 plus 3 times 1, so 17, which is the MR of ammonia. And this would give us 2.5. So we know that there are 2.5 moles of ammonia in the 42.5 grams. We can also rearrange the formula to find the mass if we were given the number of moles. For example, what's the mass of 3 moles of carbon dioxide? Well, this time we'd multiply our 3 moles by the MR of CO2, which is 12 plus 2 times 16, so 44, which gives us 132 grams of CO2. We can also work out the mass of a particular element within a larger compound, like the mass of carbon in 3 moles of carbon dioxide. For this, all we do is take the number of moles, which is 3, and multiply it by the MR of the carbon, which is 12. So 3 times 12, which gives us 36 grams of carbon in our 132 grams of carbon dioxide. And if you wanted to go one step further, you could subtract that 36 grams from the original 132 grams to find that there must be 96 grams of oxygen, because we can see that CO2 is only made up of carbon and oxygen. Now, the last thing we need to mention is that when you look at a chemical equation, you can think of them in terms of moles. So for this equation, we can think of 1 mole of magnesium reacting with 2 moles of hydrochloric acid to form 1 mole of magnesium chloride and 1 mole of hydrogen gas. And you should think of these as ratios. So if we started with 2 moles of magnesium, we'd have to react it with 4 moles of hydrochloric acid, and it would produce 2 moles of magnesium chloride and hydrogen gas. Anyway, that's all for today, so I hope you found that useful, and we'll see you next time.